Traditional mechanical grippers face significant challenges in securely grasping crops with diverse geometries. Suction-based grasping is rapid and minimizes potential damage. However, tomatoes often possess protruding stems or calyxes, which can hinder suction performance. To address these limitations, this paper proposed a hybrid robotic gripper with suction and fully retractable flexible fingers, enabling efficient and stable grasping of tomatoes. The placement of tomatoes can generally be classified into two main orientations. When the stem faces upward, the geometry is more favorable for gripping with the retractable fingers. Conversely, when the stem is positioned downward, the smooth surface makes suction a more effective option. The proposed gripper analyzes the geometry of the tomato to determine the optimal operating mode. When the stem is oriented upward, the gripper engages in finger mode to gently wrap around the tomato. When the stem is oriented downward, the gripper switches to suction mode, allowing for a quick and stable grasp on the smooth surface. The gripper consists of a suction cup for suction mode and two housings that drive the fingers. To switch to finger mode, the motor begins to rotate, causing both the inner and outer housings to move downward. As the housings descend, the fingers gradually extend outward from the body of the gripper. Once fully deployed, continued motor rotation causes the fingers to retract inward, gently wrapping around the object to achieve a secure grasp. When the flexible fingers wrap around the tomato, their length becomes a key factor in performance. Variations in the parameters L1 and L2 change the trajectory of the fingers and their final contact point. To ensure stable and adaptive grasping, the finger geometry was optimized to match the outer contour of the tomato. The graphs presented here illustrate the results of this optimization process. To evaluate the grip efficiency of the hybrid mode, an experiment was conducted. The tomatoes were divided into two groups. One favorable for suction, and the other better suited for finger grasping. The gripper then attempted to grasp each tomato according to its optimal mode. On the right, you can see the flow chart illustrating the procedure when testing for tomatoes. When the tomatoes were arranged into separate groups, the gripping performance of each mode was compared. The suction mode demonstrated the fastest operation time, while the hybrid mode achieved the highest success rate. In particular, the hybrid mode increased the grasping success rate by 71.43%, compared with suction mode, and improved the operation speed by 9.9% compared with the finger-only mode. Considering the manipulator's travel time, these values could be even higher. When the tomatoes were arranged into separate groups, the gripping performance of each mode was compared. The suction mode demonstrated the fastest operation time, while the hybrid mode achieved the highest success rate. In particular, the hybrid mode increased the grasping success rate by 71.43% compared with suction mode, and improved the operation speed by 9.9% compared with the finger-only mode. Considering the manipulator's travel time, these values could be even higher. The proposed gripper uses 12 flexible fingers to grasp objects. Although the fingers were optimized for tomatoes, their compliance allows the gripper to handle fragile items without causing damage. In addition, it can grasp multiple small objects within its operating range simultaneously.